Welcome to the Crazy Hat Chemist. So here's another video in solutions, and boy do we have a great solution here for you today. Bam! So today we're talking about boiling point elevation. This is the calculation number 1 on boiling point elevation. You see that picture right there? And this is an excellent application of a boiling point elevation problem. So that picture is showing someone with a big gigantic pot of water, and they're adding a little bit of salt to that water. So the question is, why do you add salt to your boiling water before you add the pasta? It's a boiling point elevation problem. That's what it is. It's not for taste because, of course, you're dumping out the water and that salt, that ionic compound, down the drain. Okay, so it's not for taste whatsoever. Here it is. So, what is the boiling point of a solution containing 142 grams of glycol and 250 grams of water? Okay, this is just like adding salt, but it's a little bit different. Okay, the boiling point constant for water, the solvent that is, because we know the water is the solvent because it's 250 grams compared to the 142 grams of the ethylene glycol. So the solvent is in the larger quantity, the solute is in the smaller quantity, that's the 142 grams. Okay, the boiling point constant for water, the solvent, is found in a table to be the following. That's the K, BP is equal to 0.512 degrees Celsius per molality. Okay, so this is the equation that we're going to be using here. That is the boiling point of the solution is equal to the boiling point normal. That is the boiling point of the solvent, the normal boiling point, plus the delta T, that's the change in temperature of the boiling point for the solution. Okay, so the normal boiling point for water, that is the solvent, is 100 degrees exactly. Okay, and the delta T is equal to KIM. That is delta T for the boiling point of the solution is equal to the constant for the boiling point times the Van Hoff factor times the molality. So we're going to fill in each of these into this equation, then substitute it in there, and then calculate that boiling point of that solution. So we already have the constant for the boiling point. That is a value that's always given to you, or you look it up in a table, one or the other. Okay, now we need to look at the solute. The solute is the ethylene glycol, and from the ethylene glycol we need to know that formula. That formula is C2H6O2, and you need to look at my previous video to figure out how we calculated the Van Hoff factor. Okay, ethylene glycol is a molecular compound, and therefore it does not dissociate. It dissolves in water, and the Van Hoff factor for this is 1, and I'm going to plug that right into there, into the equation right out like that. Say, then the molality. The molality is the moles of the solute over the kilograms of the solvent. So I'm going to plug these values in here. So I'm going to first solve for the moles of the solute. Here is the moles of the solute. I've taken the 142 grams of ethylene glycol divided by the molar mass of ethylene glycol, and I got 2.29 moles of ethylene glycol. Now I need to get the kilograms of the solvent. The solvent is the 250 grams of water. I'm going to convert that into kilograms, and then that is just the movement of that decimal. Okay? I'm going to divide these two numbers, the 2.29 moles of ethylene glycol divided by the 0.250 kilograms of water, and I'm going to get this value of 9.16 molality. Now I'm going to plug all these numbers in and substitute that into the KIM. Remember the KIM, that is KIM, that's the delta T. Okay, so I'm going to plug all those into the KIM. That's the constant for the boiling point in this example, the Van Hoff factor times the molality. The units of molality cancels out, and I have units of degrees Celsius. That will be my change in temperature of the boiling point of the solution. Okay, and that is 4.69 degrees Celsius. Now what I'm going to do is I'm going to plug this back into the original equation here that I have, and that's the boiling point of the solution is equal to the normal boiling point plus the change in temperature of the boiling point. And so that is 100 degrees exactly. This is an exact number. There are no significant figures. It's actually an infinite number of significant figures on that 100. Plus the 4.69. And so I'm going to get the boiling point of the solution is 104.69 degrees Celsius. That is your answer. So if you have added 142 grams of ethylene glycol to 250 grams of water, the boiling point of this is now 104.69 degrees Celsius. You can do the same thing for your pot of boiling water and adding salt. And notice that the Van Hoff factor for salt is 2, so you get a multiplying factor of a 2 when you add salt to water because it's an ionic compound. Super cool. Great application of a boiling point elevation and a colligative property example. I am the Crazy Hat Chemist, and I got a crazy hat here for you. I'm ready for a football game, and that is playing with your feet, and that's why it's football as opposed to a football game. Okay, if you like that video, give me a thumbs up, subscribe to my YouTube channel, and please pass on my YouTube channel to anyone that needs to know how to do chemistry problems. They're right here.